For this question, we're told that a ball is thrown vertically upwards with a speed of u meters per second. It's thrown from a point that is 4 meters above the ground. The ball then rises to a maximum height of 14 meters and then it falls. The first thing we want to do is calculate that initial speed. So if u, for now, we'll set it equal to the question mark, and it's at its maximum height, v equals 0. We know that it will be 10 meters above where it's thrown, so that's just the 14 meters take away the 4. And because it's against gravity, we have a equals minus 9.8. So we look at that, we want to use v squared equals u squared plus 2as. And then we just start to substitute in our values. So we have 0 is equal to u squared minus 2 times 9.8 times 10. 0 equals u squared minus 196. So then u squared is equal to 196, which means then u is equal to the square root of 196, which leaves us with u equals 14 meters per second. There was 1 mark for taking v to be equal to 0, 1 mark for using the equation, 1 mark for substituting in the values, and then the 4th mark was for getting u equals 14 meters per second. For part 2 of this question, we're asked to find the total time taken for the ball to reach the ground for the first time. There are 2 ways to do this. So the first one we'll look at is splitting the journey up into 2 parts. So firstly we'll look at how long it takes the ball to reach its maximum height, and then we'll look at how long it takes for it to fall down again. So what do we know about the ball being thrown up? Well, we know that the initial velocity is 14. We know that v is equal to 0. We know that it's going against gravity, so a equals minus 9.8, and we are looking to find the time. So we can see there that we can use v equals u plus at. So if we substitute in our values, we'll have 0 equals 14, then minus 9.8t, which leaves 9.8t equal to 14. So then t will come out as 1.42857 seconds. And that's how long it takes for the ball to reach its maximum height. Now if we look at the ball falling to the ground, u will be 0 as it's reached its maximum height. The displacement will be 14 meters. This time it's falling under gravity, so acceleration is 9.8, positive 9.8, and then we want to find the time again. So if we look at this, we'll be able to use s equals ut plus a half at squared. So 14 is going to be equal to 0 plus a half times 9.8 times the t squared. So when we simplify that down, then we'll have 4.9t squared equals 14, which will leave us with t squared equals 2.85714. So then t comes out as 1.69031 seconds. So then to get the total time, if we call that capital T, that will just be 1.42857 plus the 1.69031, which will then give us a total of 3.12 seconds, and that's rounded to 3 significant figures. There will be 1 mark for getting the time taken to reach the top. There will be then another mark for going down if we are able to see that the direction of the S and the A should be the same. Another mark for substituting in the values into our equation, and then a 4th mark will be for being able to put it all together to get 3.12 seconds. The other way to do part 2 is just to look at the whole journey together. So we know that the initial velocity is going to be 14. We don't know the final velocity, but we don't need it either. We're looking for the time. The acceleration is going to start out then as we throw it up, so it'll be minus 9.8, and then the displacement is going to be negative 4, since our final destination will be 4 meters behind where we started. So we'll be able to use s equals ut plus a half at squared. So So we substitute in our values, we'll have minus 4 equals 14t, and minus a half times 9.8 t squared. So when we rearrange all of this, then we'll have 4.9 t squared minus 14t minus 4 equals 0. So if we just put this into our quadratic formula, we'll have t equals 14 plus or minus the square root of minus 14 squared minus 4 times 4.9 times minus 4. That's all under the square root, and then that's all over 2 times 4.9. If we just put that all into our calculator, then we will come out with 14 plus or minus the square root of 196 plus 78.4, then that's over 9.8. We're only interested in the positive answer that comes out, which will be 3.12 seconds, again to three significant figures, which is exactly the same as we found using the other method. Using this method, there will be 1 mark for choosing the equation. There will then be 1 mark for substituting in the values to get a quadratic, another mark for successfully solving the quadratic, and then the mark for your final answer of t equals 3.12 seconds. For part 3, we just need to say that it's either modelled as a particle, so the ball is either modelled as a particle, or there is no air resistance. They are the two assumptions that we made for this question.